Good morning. I got some questions from the homework, so I will try to do them for you now. Question number 10. Question number 10, it says y equal e to the power of negative 3x. And we need to determine, find dy by dx and d squared y by dx squared and d cubed y by dx cubed, and use this. You will find the pattern, and from there you're gonna get dn over dx to the power of n. So the nth derivative of this function. Alright, so the first thing I would do, I will try to find the first derivative, which is dy by dx. So this is e to the power of g of x, so it is e to the power of g of x times g prime of x, which is negative 3. Then we can write this as negative 3 e to the power of negative 3x. Now, if we want to find the second derivative, the negative 3 is constant, so it is multiplied with the derivative of e to the power of negative 3, which is the same thing we get here, e to the power of negative 3x times negative 3, and this can be written as 9 times e to the power of negative 3x. Then the third derivative will be the 9 is outside, and e to the power of negative 3x times the derivative of negative 3x, which is negative 3, and that will be negative 27 e to the power of negative 3x. Okay, so do you see there is a pattern here? All of them has e to the, so I can predict that the nth derivative will have e to the power of negative 3x, because all of them has e to the power of negative 3x. Here, when it was the first derivative, it was negative 3. Here is 9, here is negative 27. So what do you think is happening here? What is the pattern? I think this is, when it was the first derivative, it was negative 3. It was negative 3 to the power of 1 e to the power of negative 3x. And when it was second derivative, it is negative 3 squared e to the power of negative 3x. And when it is the third, it was negative 3 to the power of 3 e to the power of negative 3x. So the e to the power of 3x is common, and it is here we're going to have negative 3 to the power of the power and the derivative, which derivative we are getting are matching. So this is negative 3 to the power of n. So if you want to find, for example, if you want to find the 50th derivative, it will be negative 3 to the power of 50, between brackets, of course. Yeah, it is negative 3 to the power of 50 e to the power of negative 3x. Okay, so this is number 10. I also get a question about number 11. Number 11 is find the first and second derivative. So I will do 11c. Malik and Jaylee asked me for this. So number 11, I will do 11c. Yeah. 11c says y equal e to the power of x times 4 minus x. So we need to find the first and the second derivative. So y prime, this is two functions multiplied together, so we have to use product rule. Product rule says the first, so e to the power of x times the derivative of the second. The derivative of 4 minus x, derivative of 4 is 0, derivative of negative x is negative 1. Plus the second times the derivative of the first. Derivative of e to the power of x, we all know it's e to the power of x. We can work from here as y prime equal negative e to the power of x plus e to the power of x 4 minus x, and we can find the derivative from here. Or we can factor out e to the power of x, which is common, and we can work from there. I prefer the second way, but both of them are fine. So I can write this as y prime equals e to the power of x negative 1 plus 4 minus x, which is e to the power of x negative 1 plus 4. There's we can get rid of the brackets, so 3 minus x. Now this is the first derivative. If we want to find the second derivative, we can use the product rule again. So first times derivative of the second plus the second times the derivative of the first. First and derivative of the second, derivative of 3 is 0, negative x is negative 1, and the second times the derivative of the first is this. And we can also factor here e to the power of x out, and that will leave negative 1 plus 3 minus x. We can combine like terms, and this will be 2 minus x. So this is the second derivative of the function, and this is the first derivative of the function. Okay, I hope that I answered your questions. I don't know, we still have time here, so I can go to the next lesson. Derivative of b to the power of x. Again, the derivative of b to the power of x, we're going to use Newton quotient rule. So f prime, let's say f of x equal b to the power of x. So f prime of x will be, using Newton quotient rule, limit as h goes to 0, f of x plus h, so b to the power of x plus h, minus f of x, which is b to the power of x over h. This can be written as the limit of h goes to 0, b to the power of x. This is b to the power of x times b to the power of h, so b to the power of x is common, and this will leave b to the power of h minus 1 over h. B to the power of x, we're not going to be involved in the limit, so I can take it out, b to the power of x, and I will multiply b to the power of x with the answer we are going to have from here. This is the important limit. I think I told you about it in the second or the first video, the second video. This is an important limit then when we calculate this, and I showed you how, this will equal ln, so this is equal ln b. ln b means log b base e. So this is the derivative of b to the power of x. So if I want to find the derivative of b function b to the power of x, let's say f of x equal any number other than e. So 5 to the power of x. F prime of x will equal 5 to the power of x as it is, b to the power of x, so 5 to the power of x, ln the base. That's it. So the only difference is we are going to multiply the b to the power of x with ln the base. Okay, this is the thing. Also, I still have time. If I have f of x equal b to the power of g of x, this is a composite function. So f prime of x will equal b to the power of g of x. Don't forget now ln b times g prime of x. Example for that. Let's say I have example. Let's say I have f of x equal 2 to the power of 3x squared minus 7. When I get f prime of x, it equal b to the power of f of x as it is, so 2 to the power of this. Don't forget, I have to multiply this with ln b, which is 2. It doesn't matter the brackets actually, it's all multiplied together, times the derivative of 3x squared minus 7, which is 6x minus 7. Okay, so this is the derivative of this function. Of course, I cannot multiply this as exponent, so I cannot simplify more than that. Okay, thank you so much and have a great day. I will send you the homework over on Edsby. Bye bye.